Hi guys, how are you? It's your host Mayank, and I'm back with a new topic, the introduction to application security. You might have heard lot many words which is visible in this screen like XSS, cross-site scripting, or CSR RF, which is also known as cross-site request forgery attack. You might have also heard about few things like injections, RSA, encryption, a lot many things. As a developer or as a tech enthusiast or even a support guy, you might have to deal with these on a day-to-day basis. You may be a QA for an instance, but still you have to understand what exactly is application security. So without wasting much time, let's start with this. So if I talk about application security, how does it happens in an organization? Let's say you have a big ecosystem where you have an n number of applications. There are multiple paths, multiple ways how a hacker or a which we prefer calling as threat agent might attack. It's not like you know the weakness and then you attack a system. So what threat agents do is in order to find a weakness, they attack. Once they find a weakness, now it may be possible that there are already controls in place on which your companies has already invested the time, the effort, the money, and some products, and you have those controls. But again, no control is foolproof, no control is 100% secure. So they may exploit that control and then they may get access to certain asset as well as certain function. Now just to clarify between the two, when I say asset and a function, an asset is a physical entity. It may be a file, maybe the images, some other documents, some technical documents. It may be the physical files which were uploaded by your client. It may be the personal photographs. So this is known as an asset. Another thing is a function. Now function may be like your a threat agent or a hacker get access to your system. Now, the threat agent can deform your login screen. When I say deform, it means that the entire functionality is impacted in your application and you are not even able to log into the system. It means your functionality is hampered. So those are the two major areas which usually get impacted. One is a functionality and another is an asset. Now asset means data as well. So data comes under the category of the asset. Now, what happens is depending on the type of weakness which has been exploited by the threat agent as well as the type of impact which has been caused, your business will get impacted. I'm going to showcase few things in the coming down the slide that why it is important and what exactly can be done in order to minimize it or in order to put a control on it. So let's go through it and then we'll explore it further. To handle the security or as and when the web is growing, so are the security risk. Now with the growing security risk, there was a need to come up with a unified model where we can categorize the different type of attacks and how we can solve it. So in order to do so, OWASP was created. So there are different other communities as well like CWE, CVE, and as well as OWASP. So OWASP is majorly used by a lot many companies. So let's explore what does OWASP say. So OWASP has top 10 areas where your security may be compromised. So OWASP is nothing but open web application security procedure or protocol. Some people call it procedure, some people call it protocol. Now, the number one in the list is injection. So it's not the injection that you take from a doctor, but from a techie. I believe that you might have heard about SQL injection, XML injections, NoSQL injection, LDAP injection. So this generally happens when a malicious user or a threat agent tries to execute a command or a query in your system. So injection happens when some type of command is being sent over the wire to your system. Your system interpret that command as a genuine command because it's syntactically correct, and it tries to execute the same. When it tries to execute, what happens is it gets everything, or the data or the result, which should not be sent to that particular query. So that's what injection is. So basically they inject the query or execution command into your system, and as a result of that injection, they get something or they extract something which should not be sent out. Another thing is cross-site scripting or XSS. It's very prevalent. It's the most dangerous thing, where your JavaScript, because now the primary language for UI is JavaScript. So what happens is they tries to execute this JavaScript, and as a JavaScript execution, that script tries to perform some action on your behalf which you don't know what is it. And when I say execution, it means that it can send some data, it can hijack your session, it can deform your website, it can redirect yourself to some website which is not legitimate, which is not authorized, and by mistake, unknowingly, you can enter your own details there, and those details can be hijacked. The next thing is broken authentication and session management. That generally happens when someone is sniffing your pipeline. So when a client system or a user tries to communicate with server, a session gets established between the two. What happens is, if there is a threat agent, they may try and hijack this particular channel and sniff the data. They can sniff the session tokens, they can sniff the password, they can sniff the keys which are being sent over the wire if there is no proper authentication mechanism or no proper session management. And that's where your MFA or multi-factor authentication comes into picture, and that's exactly why the companies send you an OTP or some other link to you on a separate communication medium, so that if in case your system is compromised, in that case, whatever you enter, that is being sent by a different medium which they believe or you believe is a secure way. Moreover, that particular thing is only valid for once, so it cannot be repeated. So even if a hijacker or a sniffer gets your data, still the hijacker or a threat agent will not be able to reuse that because that's already being used. Number fourth is sensitive data exposure. What happens is that the APIs generally and web applications are not, they don't understand the difference between a PI. So when I say PI, a PI is personal information. So PI has different or multiple categories like confidential, highly confidential. So the thing is that if something is not needed, it should not be sent over the wire till the time it is at most important. So we should stick to the fact that, for an example, whenever you get your credit card statement, you never see the entire credit card number. It's being encrypted with XXXX instead of the digits, and only few digits are being shown to you so that that data is not compromised. So if some data is sensitive, a person shouldn't, as a web developer or as a company, you should never send it over the wire. Next is XML external entities, XXE. This is something which is newly introduced into OWASP Top 10 in 2017, almost 2 years back. And it says that if your system parses an XML and there are so in XML is a concept known as entity which replaces the value of a specific field in the XML itself. So if your XML is not well formed, the external entities can be injected into the XML, and that injected entity can expose a lot many vulnerabilities. Next, number 6 is broken access control. So as I've already said, that it may be possible that you have an authentication things in place, but you don't have authorization in place. So when we talk about security, we talk about two things: Number one, who you are, that is known as authentication. And number two, what you can do, that's authorization. So maybe possible that in your organization itself, you are allowed to enter into the office premises, but you are not allowed to go into certain areas like server room. You will not get access to go into server room. So since you are not authorized to go into that. On the similar way, if your system is poorly designed, it may be possible that someone gets access through some back door into your system via hijacking some session of a user. But if your system is poorly written, the person can do some hit and try and can access the data of different user as well as exploit the data. So that's where this broken access control system comes into picture. Then we talk about security misconfiguration. You should use HTTPS. You should not disclose the compiler level exception messages to the user. Instead, you should send over some user friendly messages. All these some security misconfiguration which are generally overlooked by the developers comes into number 7. Number 8 is insecure deserialization. So what happens is when you deserialize a code from a serialized data, so it can expose a lot many vulnerabilities. If you want to really understand this, I can showcase it to you that what exactly can happen when you have insecure deserialization. Then using components with known vulnerabilities, that's number 9. So for an instance, you are using jQuery 1.3 and it has some security issues. Now you have not upgraded your version, and if someone as a threat agent knows that your system does not have that security feature, so they can use that particular problem or weakness in your system to exploit your system. Then insufficient logging and monitoring. If a person is trying or a threat agent is trying to do a brute force attack, for an example, your system will never realize that. If your system never realize that, your system will never try to stop that. And if you never try to stop, eventually the threat agent will be able to break your system. So that's very important that you log everything, and there are automated systems available which keeps a track on those logs, and as and when they see a pattern of security hack, they generally blacklist those IPs and they inform your security team, your support team. They can shoot out mails, they can take all the security precautions. So there are certain rules which you can configure, and all those actions will be taken so that your system is safe and your customers don't face a problem. So those were OWASP top 10. Let's move further and let's discuss about the vulnerabilities by type. Now, if we I just want your focus on the last 4 items. If you talk about the last 4 items, the first item from the bottom is cross-site scripting. As I've said, this is the most prevalent thing. As you could see, 47, almost 50% of the attacks or vulnerabilities are of this type. It comes under the critical category. Your system is extremely vulnerable if you have access problem in your system. Number 2 are SQL injection. This is again second most and very extremely dangerous because it directly impacts your data. Number 3 is file upload. File upload, when I say, it means maybe a virus is uploaded to your system. What will you do? So if we don't have proper security mechanism in place, when we give a browse functionality to the user or a client that they can upload a file, that's a problem. Then CSRF, cross-site request forgery. It's again a type where you hijack a user session and use that session token in order to make a connection with the server, and server never realizes, because when you pass in the token, server understands that this is the token, and so it's a genuine request, and they executes the command. So we'll talk about that later. Now moving further, let's see what are these different types. Looking at the first query where it says that http colon double slash students.com question mark student id equals to 117. Now just read till student id equals to 117. What is happening is you are trying to parse this query where you are saying that I need to get student where student id is 117. What has happened is that an attacker now knows that you execute in such way. Now how did the attacker know? He did some hit and tries. He tried some different types of attack, and the attacker formed a pattern. Now the attacker knows your system, so now the attacker is trying to inject something. Now what does he do is he appended one more condition. He said or 1 equals to 1. Now 1 equals to 1 is a true condition, and anything that comes with or, it means that as many conditions which are appended using or, if any of those conditions is true, this entire statement turns out to be true. And that's exactly what's happening here. So what the attacker has does, it made sure that now this is true. If this is true, and what he has done afterwards is he's put a semicolon and then two hyphen marks. If you know SQL, two hyphen marks represents a commentation. What he's doing is he is commenting out everything else. It may be like department ID, it may be like the age, date of birth. He's commenting out everything. Now, what the query will turn out is, so the web server will parse this query, and it will be turned out like this: select star from students where student ID equals to 117 or 1 equals to 1. This will be a true statement, and what will happen is, what this actually means is select star from students. Where clause is basically good for nothing, so you will get data of all the students. So this is a poorly written SQL parser. Now, second type of vulnerability is XSS, cross-site scripting. So what happens is, a user is trying to inject a malicious script. So XSS comes in different forms: persistent, non-persistent, reflected. So there are different types of XSS. So right now we are talking where the attacker has already you know uh, injected a malicious script into your system. Now since it has already injected something, when a victim tries to request for a data, the malicious script which was already injected into this page executed. When it executed, it sends the information about the victim to the attacker. When everything is being sent to attacker, it will contain your session ID, it will contain your tokens, it will contain everything that you can think of. And now attacker can play around with your, since now attacker has your session, it can do anything that it wants to with your system. So a vulnerable web page is very dangerous for your system or for the organization. Next thing is CSRF. Now what happens is, CSRF is, a session is being hijacked, and when a session is being hijacked, so what happens is, your bad guy basically tricks your victim in order to execute something. Victim thinks that it's executing the correct system, but it is not. So what is happening here is, this bad guy is giving a page to the victim. It's saying something test.html is http checkout. Victims by mistake clicked on that, or by curiosity clicked on that. It takes it to a malicious website. Malicious website sent him a page. On the UI it may look fancy, it may look some good thing, something that is attractive to a victim. Now victim by mistake entered a certain ID or some other information and clicked on a button. The moment the guy clicked on that, that request now goes to the web server, which was a genuine web server and which knew the victim. Now, since it is coming from the victim system, which is already known on where a session is already established with a vulnerable server or your web server will execute the command without knowing, and without, where victim doesn't know what exactly has happened. But this is exactly what CSRF does. So this is exactly why we call it as cross-site request forgery, where your request has been forged by someone else. Okay, so the next thing is broken authentication and session management. Again, you have established a connection with the server, and your packet or your session is being sniffed by a hacker. As soon as the connection is established, it sniffs it, and then it establishes a connection with the server. Now the server has two connections, one with the victim and another with the hacker, and now hacker can play around with the system. So Now let's talk about some statistics that exactly what happens. So if we talk about the number of publicly disclosed data breaches, and trust me, my friends, when I say publicly disclosed, it means only 20% of the actual data breaches are publicly disclosed, or even less than that, because it hampers the company. First, company loses its trust, company loses its market, company loses millions of dollars in the fee, that is legal fee, in compensation to the impacted people, and moreover it loses the business as well. So they don't disclose it. As you could see, every year the number of disclosed data breaches are increasing. By 2000, I don't have the exact number for 2018 or 2019, but if I get it, I'll put it in the description box. Now, if you look at the second section, it says that top 5 risks to do business in North America. The number one is cyber attack, and that's a very big problem. If you talk about the securities or the threats, so there are majorly the threats are involved in the threats or in the attacks. 25% of the people are insiders. It means that who knows the system. Since they know the system, they know the weakness, they know the vulnerability, and they exposes it to the third parties, to the external parties, and they uses this information to hijack the system. And what generally happens is that your data gets breached, and after a very long period of time, you realize that something has happened, and then you identify that what has happened when you reconcile the data, and then you know that what data was breached. That's what exactly the last segment talks about. So it takes, on an average, it takes 191 days just to identify if something has happened, and then more 2 months more to understand what was contained in the data breach, what data went out. Just to give you some examples, just look at this. The average cost for a data breach, average cost is 7.2 millions. And when we are talking about this, please bear in mind that we are only talking about less than 20% of the actual data breaches, because we don't have that data available. Now let's talk about the remediation cost. It takes on an average 80 days to detect and more than 4 months to resolve a security issue. Moreover, how critical it is to fix something at the development stage. Let's see. If you fix a defect at a development stage, it costs you $80 on an average, which includes your testing. It may involve your static scan, code scanning, your dynamic scanning, your penetration testing, and retesting, then creation of the reports, and so on, many other number of things. So on an average, it takes $80 per defect in development stage. When you move to the build stage, it costs you $240. When you move to the QA stage, it's almost $960 per defect. And when you move to the production, just look at it. It's enormous. $7,600 per defect. And that's something which has been published by National Institute of Standards and Technology. It's not something, you are watching it from some hypothetical situation. So it's the actual data which is talking that how much cost does it mean, how much cost, how important it is to fix something at the production level, development level. Now let's talk about the some of the biggest security breaches which happened. Number one was in Adobe in October 2013, where 150 million logins, password, names, credit card number, expiration date, all the information went missing. 40, and the best part is that they stole the 40 GB of source code. Yes, the entire source code of Cold Fusion product was stolen. Source code of Acrobat Reader, Photoshop, everything was stolen. So it was not like that they only wanted to impact the functionality, they also wanted that their systems are also impacted badly, and that's exactly what has happened. If you talk about Sony, in April 2011, the personal data of 77 million users were leaked, and the problem is that the entire PlayStation unit as well as Sony Online Entertainment were closed for 1 month. Just imagine a scenario, just imagine the scene where the entire company is being shut down for 1 month just to safeguard the existing system that they had at that time. Sony paid $15 million in compensation to the people whose data was stolen, as well as few other $1 million to legal fee and to refund to the people. And why do it happened? Just look at the last word in the slide, SQL injection. That's why it's deemed it's extremely critical to fix injections. I'll talk an Indian example where almost all the banks. So it was 3.2 million debit cards were compromised. And in the biggest, in the history, it was the biggest card replacement in the Indian history, where 6 lakh rupee cards, 27 lakh Visa and Mastercards were replaced and blocked by a combined decision made by SBI, HDFC, ICICI, Yes Bank, and SC Bank. And these are some major banks. There were few others which were impacted. I'm not naming it. One of the major ones which happened in 2017, in the mid of 2017, is Equifax. 145.5 million American, Canadian, and British customers' data and credit card numbers were stolen. The total cost of settlement included 300 million to a fund for victim compensation, 175 millions to the states and territories in the agreement, and 100 million to the CFPP fines. So just imagine how costly a security bug is. So if you have security bugs in your system, please try and rectify as soon as possible. Now, how do we identify a security bug? That's the question. Now, to identify a security bug, there are different types of scannings that can happen. Number one is SAST, or static scanning. It is also known as white box scanning because you know what's in the box. It means a developer does that because developer knows what's in the code. So this scanning is majorly done by some code analysis tools. They execute it over the code which they have written, and that static code scanning tool show or tell certain vulnerabilities which that static scanning tool thinks that this is vulnerable, and it gives you recommendation in order to fix that. Next thing is DAST, also known as dynamic scanning. Now there are different flavors to that. In dynamic scanning, OSS scanning also comes into picture. That's again somewhere which vary or lies somewhere between SAST and DAST. There's one more thing which is also known as ethical hacking, which is also a part of dynamic scanning. Penetration testing, which is again part of the DAST. Advanced penetration test, or AAPT, which is again part of DAST. So there are different flavors of DAST. IAST is interactive, so it's like a combination of both. So what happened is that they clubbed these two things together into a single component or a product, and they sold it out, calling as interactive application security testing. So both the scanning takes care or are taken care by a single software, and it scans your code and then try to do some injection on the same scanned code, and then make a decision whether a particular finding by a static scanning is a bug actually or not. Then comes the RASP, and as you could see, I have crossed striked out testing. Since it's not a testing tool, it's a security measure that you take. So it's like runtime application security protection. If you remember OWASP top 10 last point, number 10 was insufficient logging and monitoring. So that's why this is important. So what happens is your RASP is an application which keep monitoring your log as well as incoming request. And what it does is it tracks the usage of your application by the different requests. And if it finds out that something is going south, something is going fishy, it triggers certain rules which you can configure that can involve sending out mails to your support system, shutting down or completely cutting off certain systems from the load balancer, blacklisting of some IPs, or different type of things in order to stop the brute force attack. Let's talk about the SAST versus the DAST. What exactly are the differences? So as I've already explained that SAST is a white box or open box testing where you know the code, A black box is something where you don't know what's happening. So it's like a black box given to you. A login password are given to a dynamic testing team. They try and penetrate your application. They try and penetrate your break your system using certain tools like Burp Suite and Qualys. There are so many other tools available. In the SAST, your application needs the source code, whereas in DAST, you need an application which is running. In the SAST, you find vulnerabilities in the earlier stage. It means in the development stage. Where you in the DAST, you tends to find it somewhere when you have already moved or passed the development stage, and you have already also passed the QA stage. Your system is working, and that's where you are towards the end of the SDLC lifecycle. Yes, to fix something when it is found in SAST is quite easy because developer already owns the code, it knows the code, and it can fix it very easily. Whereas it is expensive to fix something in DAST because it has to come all the way to the back to the developer. Then again, developer has to fix it, test it, then deploy it. Then again, a DAST has to run. So it takes quite a bit time. SAST cannot discover anything which can happen at runtime. Like SAST cannot tell you whether your system is prone to denial of service attack. It's something that is not at all relatable to SAST, but it is relatable to DAST. So DAST is meant for discovering runtime environmental or environmental related issues, whereas SAST is specifically about the code vulnerability. um, Usually SAST has so many, there are almost for every language that you can think of, every framework that you can think of, there is a SAST tool available. And so is for the DAST, because DAST doesn't bother or doesn't care which tool you have used or which language you have used in order to create your web application, because all it needs is the credentials to enter into your application and tries to exploit it. So it's something that doesn't matter what type of language you have chosen to create your application. But all in all, if you are choosing to go for SAST, you should go for DAST as well, and if you're choosing to go for DAST, you should go for SAST as well. So they both go hand in hand, and it's a very good combination, and that's what emerges IAST out of this. So as you could see here, as I've already explained here, that in development stage, SAST gets applied, not DAST. In QA, both gets applied, and same as it goes into the production as well. Now let's talk about the timeline, how it works, and what is applicable where, what is the accuracy, and all that. So we talk about SAST. Its speed is good, similar to IAST. DAST takes time because person has to do it manually. RASP is again instantaneous because it happens at runtime. They are applicable to different environments. Uh, what happens in SAST is it analyzes the static code. In IAST, it analyzes the code as well as behavior. In DAST, multiple HTTP requests are exploited, and in RESP, it monitors your system. When we talk about the continuous security testing, DAST is not applicable there. Similar to CI/CD integration, RESP and DAST are not applicable to the CI/CD pipeline. So if you already on a DevOps model, then you have to go for either SAST or IAST, because that cannot be injected or integrated with CI/CD pipeline. However, why? Because RASP is first of all not a testing tool; it's a monitoring tool. So that's something which gets applied onto running website, and so is DAST. Integration, when you talk about, then you need some type of tools which gets connected or plugged into your IDE. It may be Eclipse, IntelliJ, Visual Studio Code, Visual Studio Server, system, whatever you are using. Similar to DAST, you don't need an integration. Similar to RASP, you don't need an integration. In IAST, yes, you need, because it also analyzes your static code. If we talk about the accuracy, the highest are IAST and RASP. DAST is sometimes, like for an example, you are getting a content type as application slash JSON. So sometimes DAST thinks of it as it is an XSS, but whereas if something is JSON type, it's a plain text and the browser will not execute it, but DAST thinks that it is an XSS. So those kind of things happen in DAST. So It is again about the due diligence of your application security champion that you have in your company or organization. They are the ones who can mark your issue as a not an issue, or who can overlook this particular type of issues which are which are exposed by testing. When you talk about the actionability, SAST you can take, IAST of course you can take, but in DAST it's a bit hard, because once you have the findings, you have to debug your code and then go to the exact line and understand what's happening. Whereas in SAST and IAST, they can directly point you to the location where they can tell you the code number, they can tell you the file name, and exactly even they highlight the words or the variable names or method names as well where you have the problems. When we talk about the RASP, it's again, it's high detailed information are given, like this particular IP address has sent 2 million requests in the last 10 seconds, and that is the reason why it was blacklisted. So it gives you all the details and all the detailed information that is required. Well, guys, that's all for this particular overview of application security. Next video. Thank you so much. Have a nice day. Bye bye.